Well, hello, my name is Peyton Ulrich, and I'm going to be going over a brief introduction to split plot design. So let's start off with a scenario. Let's suppose that a researcher is interested in studying the effect of two different factors. First, the floor resurfacing method, and second off, the brand of basketball on the bounciness of a renovated basketball court. So again, we have two different factors here. The first factor is the floor resurfacing method at 2 levels, and the second factor is the brand of basketball, again at 2 levels. Here's kind of a little graphic to display the treatment structure here, which is a 2x2 factorial with 4 total treatment combinations. And the response variable we're going to say is the bounce height measured in inches when the basketball is dropped from 4 feet above the floor. Let's suppose that this researcher goes through and performs a pilot study and does power analysis, and they find that they're going to want at least 4 replicates per treatment combination. So what that means with 4 total treatment combinations and 4 replicates per treatment combination, that we're going to want a total sample size of at least 16. And then let's also say that just kind of a practical constraint here, that the researcher is in contact with the gym manager of 4 different basketball courts that are wanting to renovate their basketball court, and they're willing to participate in this study. But it's not really practical for him to find anybody else because he's not able to find anybody else who's really willing to do a renovation at this time. So we're limited to only 4 basketball courts in this study. So let's look at kind of 2 different classical design strategies. First off, the CRD, completely randomized design. In this case, since we said we wanted a total sample size of 16, we'd want to divide the courts into subsections, basically each quarter of the court, giving us a total sample size of 16. So our experimental unit is going to be each quarter of the court. We can then randomly assign the treatments to each experimental unit, so to each quarter of the court. That's going to result in an ANOVA table. The first 2 columns of an ANOVA table look somewhat like this. But we might have this potential problem here, which is court-to-court variability. So court 1 and court 2, court 3, they all might have slightly different effects on the bounciness of the court or of the basketball. So there's a potential solution that we could use here, which would be another experimental design, which is RCBD, using blocking. So let's go to this next design, which is randomized complete block design. So in this case, we're now going to be blocking for court. We're going to have 4 blocks. Experimental unit is still each quarter of the court, but what we're going to do a little bit differently here is rather than fully randomizing the assignment of treatments to each quarter of the court, we're going to randomly assign treatments within each block. So we're going to, within each court, assign each treatment combination 1 time. And this is going to be what our ANOVA table looks like. But again, we might have another problem, and this is more of a practical constraint, which is that we might only be able to use each resurfacing method once on each court, meaning that we can't resurface 1 quarter of the court with 1 method and then another quarter of the court with another method, etc. That's probably just not practical to do in terms of the resurfacing process. So that's when our split plot design comes into play, is in this type of situation where we have 1 factor that is difficult to vary or that's hard or infeasible to vary, something like this. So let's talk about how we could use split plot design in this situation. So the first thing that we want to do is we randomly assign the whole plot factor, which is the resurfacing method, to each court. So we said that we can only assign 1 resurfacing method per court. So we're going to go ahead and do that and assign 2 courts to method A and 2 courts to method B. And then we're going to randomly assign the second factor, or the split plot factor, which is the basketball brand, to each quarter of the court, or to the split plots. So we now essentially have 2 different experimental units here. The first experimental unit is the whole plot, or the whole court, and the second experimental unit or subunit is the split plot, or each quarter of the court. This is what our effects model is going to look like. I just wanted to point out a couple terms here, and that's that first off, we have 2 different error terms, the whole plot error, and then a little bit later, we have the split plot error. So the whole plot error is essentially the error corresponding to each whole plot unit, so each court. And the split plot error is the error corresponding to each subunit or each split plot unit. So what this essentially means is that we have kind of 2 different experiments within an experiment. We have the whole plot experiment, and we have the split plot experiment, each with different experimental units. We have a whole plot unit and a split plot unit. And this reflects in the ANOVA table as well, where we essentially have 2 different sections. One's kind of the whole plot section of the ANOVA table, and one's the split plot section. And when we're looking at the whole plot section, we're going to be using that main plot error term to calculate our F ratios. And when we're looking at that split plot section, we're going to use the split plot error to calculate our F ratios. So that's kind of the general overview of split plot design. Let's quickly summarize all this. First off, a little bit of a history lesson. Split plot design actually originates from the agricultural field, hence the terms of whole plot and split plot, as in plots of land. It's a special case of the factorial design in CRD or RCBD. It's necessary or useful when one factor is more difficult or impractical to vary than another. So in this case, resurfacing method was more difficult to vary. We can only do it kind of once per each court. And in some cases, it's going to be more practical or efficient than the CRD or RCBD. And then again, in essence, there's basically two different kind of mini experiments within this experiment. One with the main plot factor using the whole plot as the experimental unit, and then one with the split plot factor using the split plot as the experiment.